GPSX standard license includes our regular Mantis 2 model that you've all been using regularly, and also the Mantis 3 model. This is actually something new. Previously, our greenhouse gas and carbon footprint model was an additional add-on. We have now rolled that in, and it is just a standard part of GPSX from now on going forward. So everybody will have access to both the regular Mantis model and the greenhouse gas model as well. So these, in addition to that, everybody will also have access to our new sulfur and selenium model too. So this one, as I mentioned before, is really taking the Mantis 2 model and expanding it, adding new components, adding selenium and adding sulfur. And you can see here we have lots of different forms of selenium here, selenate, selenite, elemental selenium, because we're going through this reduction process with the biomass, and same thing with the sulfur, many different forms of sulfur that you can find. And we also are supporting modeling all of that, all of those transformation processes by adding 7 new biomass types to be able to do that. So you'll see here that we have our selenium reducing biomass, and then we actually have several different types of sulfate reducing biomass that use different forms of substrates for COD, and also a sulfur oxidizing. So we're doing both sulfur oxidation and reduction, and we have all of these biomass type systems in this, biomass types in our model to be able to support that. So there's a lot going on there. Our Mantis IW is an industrial wastewater treatment. We used to have another model, and we published it actually quite a number of years ago, called Mantis IW, that was a much simpler version of what we've implemented now. So this new model actually takes the Mantis 2 structure and expands it for industrial wastewater components. So there are a large number of new components, but it still has all of the stuff that you would normally be used to seeing in the Mantis 2 model, like the gas transfer and precipitation and pH models and so on. And we've supplemented that with 10 different types of hydrocarbon groups. And each one of those is undergoing biodegradation, as you would normally expect in these models that we have, the volatilization and actually sorption for each of those. And they all have their own individual sets of parameters that describe that. So in that way, it's actually somewhat taking from our information that we've learned over the years from our ToxChem package, being able to use that type of approach combined with the Mantis 2 modeling sophistication that we have in GPSX. So you can see here, here's some of the different types of substrates in our industrial wastewater treatment model, the industrial version of GPSX. So we have aliphatic compounds and organic solvents and aromatics and so on. We have included oil as well. We actually have a new object there for the oil-water separation in this library. And then we have 5 generic user-defined industrial compounds that you can actually specify what you want those to be and include them in the system. And lastly, our Mantis process water treatment model is, as I mentioned, for ultra-pure water treatment. And so we've been developing this now for a couple of years, using it in-house for our own projects, and it's now being released for GPSX. So this is for doing primarily chemical and physical treatment, although it does still have the biological treatment aspect in there if you want to use it as well. What we're seeing it being used for right now is process water treatment. So for manufacturing facilities want to model the treatment of the water that they're using in their processing facility. For water reuse, so treating effluent wastewater to a higher level so it can be used for other purposes, and for drinking water treatment as well. So as I mentioned, focuses on physical and chemical, and it has a number of different new unit processes and new state variables that are available in the model. You can see here that the components that we have are a little bit like some of the precipitates that we have in the wastewater version, but we have expanded that by quite a lot. And we have a large number of new unit process objects that are available for this library only. So you'll see here things like cooling towers and boilers, evaporators, many different kinds of ion exchange and neutralization, lime softening, and so on. So these are all things that are available for this specific library. So you can do things like drinking water treatment like this. Okay, so those are all new. Specifically, as I mentioned earlier, Mantis 2, Mantis 3, and the Mantis Sulfur 2S, we call it, sulfur and selenium libraries. Those are all available to everybody as part of the standard license. However, Mantis IW, the industrial one, and Mantis PW for the process water those are actually add-on modules that will be purchased on top of your existing license. So, okay, so there are now, as I mentioned, 13 new objects in GPSX. This is actually the biggest number of new objects that we've ever added to GPSX in one shot. So we have a number of things like a new influent object to represent rainfall. We have Aerobic digester that's been updated and calibrated. A new pipe object to represent long distances and hydraulic lag, so to speak. And a customizable 2-outlet black box model. We have a new UV disinfection model, flat sheet MABR, aerobic granular sludge model, thermal hydrolysis and sludge incineration models. We also have reverse osmosis, passively aerated biofilm. That was a special project where we worked on a biofilm system that had these sheets with air passing over them and so on. Aerated struvite recovery and sludge drying. So I won't be able to go through all those today. I'm going to do 5 of these, and we'll pick up all the other ones in the next month's webinar. Okay, so let's talk about the one that probably we had the most requests for, which is the aerobic granular sludge process. So this is a 2-phase solid liquid model that combines the best of what we do with our biofilm models with the way that we operate our SBR models. So this allows you to model it in the way, like the Narita system, where you will fill and aerate and then have anoxic times, and then you decant and let it settle, and then you decant. So it needs a cyclical operation settings. As you'll see, it has a full biofilm model, but it's been modified in order to work for granular sludge as opposed to biofilm growing on a fixed surface area media. That's one of the aspects that was where we focused quite a lot on the development of this, is that granules grow differently than the way that biofilm grows on a piece of plastic that has a fixed surface area. So as the granule gets bigger, the surface area changes and so on. So that needed a bit more sophisticated model than the way that we would do it. So we actually allow for not, some of the other earlier models that we'd seen published were very much a fixed granular mass. This is now allowing us to grow new granules. So you can start from a startup position and model how that's going to grow as we grow new granules and they get bigger and so on. Okay, so let's take a quick look at that. We have, as you may know, a sample layouts feature in GPSX that allows you to load up. I think we're getting up to about 80 layouts now. So if I go to unit process examples, you can find in here an aerobic granular sludge object. And so let me close that. And we can see here, I'm just going to open up the menu so you can take a quick look. We have our physical menu where you specify the reactor size and so on. And then you also have these types of menus here for setting the cycles, and it's very much the same way you would do this for the SBR. So if you're familiar with setting up an SBR, it's very much the same kind of way. And then many of these other things are very much like our biofilm models as well. So I just want to very quickly run a short dynamic simulation here so that you can see things. Like you can see here our granular mass moving along. That's pretty much being held constant. This is the volume of the reactor. We can see here there's periods where it's pumped down and then filled back up again as we were decanting off some of our flow and some of our treated liquid. And then we can take a look actually at the concentrations inside the reactor. So without going into a lot of detail, you'll see here, of course, that the DO goes up and down, and there's aerated periods and anoxic periods. And we can see in this graph here, green is the ammonia. So periods where the air is on, we're seeing some nitrification happening. All that ammonia is starting to be removed, and we're generating nitrate, which is the black line. And then that's undergoing some denitrification here during the anoxic periods. So as those things go back and forth, we can then use the various parameters to look at the capacity of what this particular sludge, granular sludge reactor would be able to treat. So it works very much the same way. It's just a little bit of an advance of, it's one of the more complex models in GPSX now, where we've combined SBRs with biofilm and then modified all that to work with granules. About our new flat sheet MABR bioreactor as well. So as you know, we have a hollow fiber MABR model that exists in GPSX. It's been out for a few years now. So we have also produced a flat sheet. So you can imagine it's a flat spiral round sheet that are inside these reactors here, and then we have a number of those in series. We worked with a vendor who makes this type of technology, and we're able to calibrate the model well to a full-scale operation. And again, you can find that by going to our sample layouts menu. Let's look at these unit processes, and if I go down here, we can find the flat sheet MABR. And I'll just very quickly run it at steady state here. You can see this particular unit, for the example that we've set up here, is being used to handle, take some of that load of BOD removal and nitrification up front here, and being able to do that by specifying things like the number of modules in series, the number of spirals that are found within each module, and then we calculate the total surface area from that, and then we apply actually very much the same type of biomass that we do in, or sorry, biofilm model that we do in our other biofilm models in GPSX. So you can look at a lot of the details around what's going on in this MABR unit. So we talk a little bit about the reverse osmosis unit. This was actually work that we started out in the process water library, but then have now brought it into GPSX as well. So you specify the deep physical configuration of these RO units, and then you can calibrate the removal efficiency. You can use the operational settings for things like feed pressure and so on. And then we can remove soluble components out of that waste stream. So I have another example of that, sample layouts, unit processes, and let's go to reverse osmosis. And so this would be typically used in a situation like this, where this is probably a plant that would be doing water reuse. So after an activated sludge process and then membrane filtration, there's applying some reverse osmosis technology here to be able to get a very high quality effluent and some brine that contained the concentrated soluble components that were removed. So if we just run this at steady state, and I'm going to hop over to the reverse osmosis unit here. And so in this case, we're calculating things like osmotic pressure and then an efficiency of removal of those soluble compounds based on either their type of charge, like the type of compound that you have, whether it's a monovalent ion or multivalent ion and so on, or you can actually specify it directly. You can actually specify for each one of the soluble state variables that we have in the stream what its removal efficiency is. All right, I'm just letting this thing come to steady state here, and what you'll see is as we go through and we compare the feed concentration versus the filtrate concentration. This is actually something that was kind of buried away in one of our other influent objects, and it never got very much use, so we kind of reinvented it and brought it out and gave it its own new object. The idea behind it is you specify a rainfall event in some sort of inches or millimeters per hour, and the catchment area, and there's a few other model parameters, and what it does is when you give it a rainfall event, it will give you a time series of water flow coming into the plant. And the idea behind that is that we can then sort of mix that with the regular wastewater flow, and then be able to see sort of the typical behavior that you would get when you have a wet weather event that kind of dilutes the flow coming into the plant. So in this layout, we don't have the whole wastewater plant here. We really just have the influent part, the regular raw sewage coming in, and our stormwater. And what I'm going to do is I'm going to show you the flow rate here, and I'm going to run a long simulation because otherwise it's going to go by too fast. And I'm going to make a bunch of rain happen here, this rainfall depth. If I go along here, and we can see the flows coming into the plant, and if I just go up and down like that, make a rainfall event, you can see it takes a while for the watershed to collect and deliver that flow to the plant. Eventually it goes back to zero, but I can make a bunch of weather happen one after another. The idea behind this is that you could theoretically have something generating some weather for you, or you could read it in from a file, or use a random number generator, whatever you like, to be able to have some weather, and then the hydraulic delay of all that flow coming to the plant will be handled by the stormwater model. And you can also characterize this influent. Right now we've characterized it as essentially more or less clean water. Probably, if you had ever run into an aerobic digester before in the work that you've been doing, you probably used just a regular completely mixed tank with diffused aeration. That was perfectly a great way to do it. That's the way we always did it before. However, we got an opportunity to work with a slightly new and updated alpha value for the diffused aeration that is actually a model. Normally we set alpha as a constant in our models, but here we were able to correlate it to the solids concentration. So, and that really works well. We had a couple of really good papers on that where we were able to find nice correlations that showed how the alpha decreases with increasing solids content in that digester. So I won't run the simulation now since I'm running a little bit long, but I'll show you, for example, here where in the diffused aeration menu, we now have a correlation. You can either set it or you can correlate it to the solids concentration, and we'll calculate an alpha value for you. So as I mentioned, there's so much new material in this new version 8 release that we had to break it into 3 webinars. So I'll just very briefly touch on sort of all of the things that we have before going into some more detail about some of them. So in addition to our regular libraries for our comprehensive model, Mantis 2, which is the one that most people use, and our carbon footprint library, which is the Mantis 3 model, we have a new library now called the sulfur and selenium library. So we're doing sulfur reduction and oxidation and selenium reduction, and we have new biomass types and other things going on in there. We have a process water treatment library as well, so that means that's water treatment as opposed to wastewater. Primarily could be used for drinking water modeling, it could be used for process treatment for industry. And we also have a petrochemical wastewater library for treatment of refinery wastewaters as well. So those are all new areas that we've been moving into, and so you can see more details about that. And last month's webinar, we have 13 new unit process objects, and I'm going to be talking about some of these in more detail today. We have new drawing board features, and as I mentioned, new data handling and data validation tools. There's new ways to output your information, such as new mass balance table diagrams, new word report, data summary features. We've improved the menu functionality to try and condense things and make them a little easier to navigate your way around to the information that you're looking for. And of course, as I mentioned, we've updated many of our existing models, including the Mantis 2 model, where we, as we usually do every release, we sort of touch up the calibration a little bit based on our experience and using the Mantis 2 model over the past year or two. One of the other key features of the new version is integration with Python, the Python programming language. Okay, so let's get into some details about things that we never got a chance to talk about last time. So one of the things that we looked at doing was a way to make it easier to set up dynamic files for you to be able to read data into GPSX, either to plot alongside the simulation or to drive your simulation if you're reading in influent flow and concentrations, for example. And there are lots of different ways to do that we've had over the years with GPSX. So, of course, the most popular ones are the Excel spreadsheet and the tab delimited text files, but you can also connect directly from or to an SQL database. It's not used very much anymore, but we do still support the idea of reading directly from Fortran. And then also, as I mentioned, we have this new way to connect Python directly as well. So those are options, but by far the most popular version is, pardon my phone going off there, the Excel spreadsheet. That's the one that most people use to be able to read things in. So what we did was we then created this file creation wizard. It's a way to nicely set up things so that you can have the spreadsheet formatted in the way that GPSX needs to see it, and so you can just cut and paste your information in. So this is a new button at the top of the GPSX window in simulation mode. You will see this new data files button here. So, and what you can do is if you click on that, it will open up the data files menu. This used to be only available from the scenario menu, but we've now moved it into its own button. And when you click on the new function here, it helps you try and set things up so that you can work with a blank spreadsheet that's already been formatted the way that things need to go. So what I'm going to do is actually show you what that looks like. So here is our GPSX layout. All I'm going to really do is model an influent object in this case. So what I'm going to do is, if I wanted to, for example, read in a data file and create one where it would include the influent flow over time, I first of all need to have whatever parameters that I want to be able to plot up on the sliders here. So basically drag the parameters that you want to have in your spreadsheet up there, and then I click on that data file, and then now this allows me to make some decisions about what data is to be used in what scenario and so on. But let's just, for argument's sake, we're making something brand new. We now have this new data file creation wizard that takes you all through the steps. So right now we're going to be creating a file that's going to read input. It's going to read data that is used for the influent flow. And so I can now select from the ones that were available here. So there's only one, we'll pick that one. And you can make a list here of the different things that you want to have available in your spreadsheet. And then you click next, and then you can set this out as the Excel spreadsheet that you want to be able to generate. So you can name it whatever you like. I'm just going to leave it as it is right there. And now it will prompt you, and it will open up that Microsoft spreadsheet. It's now named. It's been added to your either the default scenario or whatever scenario you had specified. And now it's all ready to go with the appropriate headers. And then you can just paste in your data right here. Time in the left column and your flow in the right-hand column. So you can use whatever methodology you like to get this set up, but this is a nice way to just sort of get things done quickly and easily as needed. So we've added a few new features now with our Influent Advisor tool as well. So just to refresh your memory, Influent Advisor is a tool that basically allows you to assess and potentially debug any problems that you might have with your Influent data. So you'll already know that you enter in all the information in your the left-hand column, and it calculates all the state variables and all the composite variables. And if you ever run into a problem, like this little demonstration I've set up here, where this particular thing that's being calculated here is showing that it's a negative value. And that's going to indicate that there's some issue that you might want to be able to deal with in your system. So what this means is you need to probably change some fractions, or maybe you should just take a second look at some of the numbers that you're using. What's going on in this particular example is that my ammonia and TKN are almost equal to each other, not leaving enough nitrogen to go around and be spread around all the other places that it's required, like the amount of nitrogen that's tied up in the biomass and tied up in the inert materials and so on. So this is fine, but what happens if I have a large data set where I have different numbers for every hour for a month? That's a lot of entering information into Influent Advisor. What I would rather do is have a tool where it can do that for me. So this new data validation tool basically reads from your spreadsheet all the values that you would be reading into Influent Advisor, and it does all the calculations, and it makes a color-coded report for you that highlights any place where there may be a problem. So that is another button down here, another brand new button in the lower left-hand corner down here, the data validation tool, and I can show you that right now. So I have previously made a little example of that. So right now I have a series of things that I'm potentially reading in to the system, and I have a nice spreadsheet already set up with those values ready to go. But I want to check and make sure that all of the rows of that spreadsheet, all of the time steps where I'm reading in data, that they all make sense. I don't want to have, you know, it may be really hard to be able to see, even if you take averages across all of your time steps, potentially a spot where maybe there's a concentration problem just for a brief period of time. So what I can do is I can go to Influent Advisor and I can click on this data validation button down here. Now, just briefly, I'll take a really minor detour here just to point out that we've actually made a couple of other changes here as well. You can now scroll the input part of the menu here independently than of the rest of the menu, and also we now can open and close many of these variables groupings as needed. And the reason for that is that as we've added more parameters to our model, more state variables and also more composite variables, these menus have become quite long. And so rather than having to scroll up and down, we allowed that to all sort of happen independently of each other. So what I'm going to do is I'm going to show you what that looks like. So over here, you'll note that when I'm in modeling mode, I can click on this button and I can specify the input file that I have already created that has those columns of data in it. So let's browse to that thing. And then now I'm going to create an output file where it will read all of those things, perform Influence Advisor on every single time step, and then create an output for me. Now we throw in a default name. I'm just going to stick with that for now. And then we click on here to validate that data. So the amount of time that this will take is actually a function of how many time steps and how many rows there are in your Excel spreadsheet. So here I have time steps of about 15 minutes for a month. And so this will be done here in a brief moment. Okay, so let's open that spreadsheet and see what that looks like. So you can see now what I'm going to get out of this is actually the state variables all the way across here, across all of the columns, and all of the composite variables as well. And it's doing it for every one of the time steps that I supplied in that spreadsheet. So you'll notice immediately if there's a problem. We highlight the row in yellow where there's at least one column where, at least one column where you have some negative values. So you can see here there was a brief period of time where one of our concentrations, which one, the XPS, so our phosphorus balance wasn't quite right. Like maybe the data that we were reading in, the total and soluble phosphorus numbers didn't really jive with each other. And so therefore we ended up with some slightly negative values as we went along. So it's a nice, easy way to sort of troubleshoot your data, figure out if there's any real issues in there. And so it's a nice way to sort of highlight those. I know there's another example down here at the bottom where we were getting some negative values of inert materials and so on. So it's a nice way to handle and just double check and validate your dynamic data before you get rolling. Okay. And also, in terms of generating results, you want to be able to get those out. And as you know, we have our Excel spreadsheet report. It generates lots of tabs of all of the data that's available, and you can get time series and columns of results out that you can then make some nice graphs with, and all of the graphics that are in GPSX come out as well. But now we've created, in addition to that, a Word report. So the idea behind this one is this is a sort of a nicer, more condensed version. It has most of the important inputs and outputs already nicely formulated into tables in Word. And so you'll end up with a table that shows you, okay, for this particular object, here's what you changed away from the default. We'll list the parameter and the units, and then we list the default value and then the value that you used. It actually uses underneath a user-definable template for those reports. And so if you would like to customize that and insert your own company graphics or whatever you might like, that can be done. And the overall design of this is it's kind of there to be really something that you could easily generate and put in as an appendix into your report that is basically just a short modeling discussion. So this is also a button. This was previously the Excel report button. We've now changed it so that it includes both the Excel report and the Word report. So I am going to just show you that really quickly so you can see what that looks like. So you'll load up any simulation that you want to be able to run. Here I'm just going to run a steady state solution to this particular very simple model. And then once that's done, this button up here will become active, and then we can generate whatever kinds of reports that we like. So you can see here, here's our standard Word report. There's different options you can include or exclude certain things. I'm just going to generate it with the whole works. And it prompts you where you would like to save that. And then once it's done, we will open that and take a look. All right, and so you'll see we actually put in a nice cover page. We put in a description of your layout, whatever you entered in the plant-wide properties file, and then an image of the layout itself. And then, as I mentioned, all of the input that you used for your model. So for every one of the objects in your layout, we've listed all of the parameters that you made changes to. So all of the default values are shown in one column, and then the value that you used is in the next column over. So we also include all of the output tables, all of the images, and nicely formatted tables there as well. And so I'm also going to slide to the end, just to point out that if you, you also get the output graphs as well. And then when you get to the end here, if you've made any parameter notes, so you'll notice that there's that notepad button just to the left, just to the right of all of the parameters in all the menus. If you ever made any notes there, those would be appended to the end of this report. I'll also mention the quick tips menu. So you'll notice this is going to be turned on the first time that you go to use GPSX, but you can access it actually any time that you want to by going to the help menu, selecting on quick tips. It's basically a small window that will highlight and give you a little bit of description about one of the features of GPSX that you may or may not know a lot of details about. So the idea is we're trying to make it so that people can be aware of all of the features in the software. I've had lots of experience over the years of giving GPSX training to people, and they'd say, oh, I really wish you had, this certain feature. And I'm like, oh yes, we actually do have that, but they just didn't know where to access it. So what we've done is make this little thing that you can pop up at any time. You can have it so that it pops up every time you start GPSX, and you can just browse around and learn a few new things. And there's always a link to places where you can get more detail about that feature.